Welcome to all. I am Rekha, Assistant Professor of EC Department. I am here to present on the topic of transient analysis. So, as we all know that it is one of the syllabus that is related to ECE. So, under the network systems and signals, we have transient analysis. So, transient analysis already we have discussed about the weightage and what is about the transient analysis. So, transient analysis is nothing but a time transient. That is, when a signal moves, say from input, when we give some input signal, when it moves into a next state, what is the transient response that it has is the time transient response of a system. So this is all we would have seen. So when t is less than 0, we call it as switching state, that is before switching, just before switching, and t to 0 call it as instant of switching, and t is equal to 0 plus is just after switching, and t greater than 0 is just after switching, and t when it tends to infinity we call it as steady state switching. We know the basic components of the circuit. So that is R, L and C. So R, it resists the flow of current. So L is the energy, that is L is an inductor that stores the energy in the form of magnetic field, and C is a capacitor that stores the energy in the form of an electrical charges. So next, moving on to this, it is nothing but V of t is nothing but how V of t varies with respect to time, that is R into I of t. Similar way, V of t is equal to L into the differential of the di of t divided by dt. So when we want to calculate, we take an inverse of that. So it is nothing but I change it into an integral. So 1 by L V of t into dt. Similar way, we have capacitor. So capacitor is given by different derivative of the voltage. So derivative of the voltage with respect to time. So when we want V of t from that, it is taken as 1 by C integral of I of t into dt. So we'll discuss some of the problems involved in RLC. First, when we move on to say in this series RLC circuit with a DC excitation, the entire state voltage will drop across whom? It has been asked. Suppose when we say we have a resistor, inductor and a capacitor that are being in series along with an voltage source. So when this circuit is so, I apply an voltage source. So when I apply an voltage source, say when it is under the steady state, so under steady state, I apply a condition, say that is your time is to infinity. So my L will be under short circuit and my C will be under open circuit. So when I replace this L by a short circuit and when I replace the C by an open circuit, it will become as a resistor followed by instead of an inductor we will have a short circuit, and then we will have a capacitor that is by an open circuit, and you will have an voltage across this. So this is what is our voltage. So we have to calculate what is the voltage. So I can write it as this is an voltage. So when I apply KVL, it is V minus 0V. For this resistor you will have a 0 voltage, and this is again a short circuit, so this is also 0, and this is an open circuit, so 0 voltage. So you will have VC minus 0, which is equal to 0. So I can tell that V is equal to VC. So the answer for this will be, say it is across, the voltage will drop across the capacitor. So next is we have to find out, next problem is this. So we have a current source with 2 amperes. We have to calculate what is the IL of 0 plus and V of 0 plus and IL of t for t greater than or equal to 0. So for this condition we have to first sort out what is when this switch will be under on and when the switch will be under off condition. So for this we have to take the value of t. So t, when it is say less than, it is given to be as equal to 0, at equal to 0 the switch will be open. So what happens at t when it is less than 0? So when your t is less than 0, what happens is that the circuit will be closed. The circuit remains closed for some amount of time. So it enters the steady state, so which indicates that t will be equal to infinity. So when t is equal to infinity, what happens to the current? The current will be flowing across this inductor and this resistor and this resistor also. So we have to measure what is the current across this. So I have to measure what is the current, that is your IL of t. So IL of t will be equal to the same current that flows across the that is your 2 amperes of current that flows across this. So that is your 2 amperes of current. So after this we have to calculate for t is equal to 0. So under the t is equal to 0, my switch is under open circuit. So we do not take that into consideration. Next, we have been asked to find out the value of t greater than or equal to 0. So greater than 0, which indicates that it is 0 plus. So we have to find the value of 0 plus. So when we find out the value of 0 plus, it is given as IL of t will be equal to ISS plus e power minus t divided by tau. So we know what is IL of t from this. So it is 2 amperes. Before I calculate for IL of t, I have to calculate for ISS. So ISS is given by, so ISS usually when you short circuit, it will be saying that there is no current in the flowing across the element. So this will be 0. So I can solve for tau here. So IL of t will be equal to, since my ISS is 0 and it is k into e power minus t divided by tau. So how will I find out the value of k? So I know what is IL of t, it is 2, which is equal to k into e power t minus tau. So at time t is equal to 0, this will become as 2 is equal to e power 0. So k value will be equal to 2. So after I find out the k value, I have to substitute in IL of t. So IL of t will be equal to 2 times of e power minus t by tau. So after that, I have to find out what is the value of tau. So tau is given by L divided by R equivalent. So L is 4 and the R equivalent is also given to be as 20. So here the value of resistor is 20. So it is given as 1 by 5. So the tau value is 1 by 5. So what my final answer of say IL of t will be equal to 2 times e power minus t divided by 1 by 5. So it is 2 times of e power minus 5t. So this is what is the current, that is IL of t when my t is say greater than or equal to 0. This has to be found out. Next we are asked to find out what is my V of 0 plus also. So when I take a differentiation of this IL of t, I will be able to calculate what is the V of 0 plus. So we'll continue here. So we have the third sum that is given with respect to voltage. So when we have solved in the last sum, we solved it with respect to say current source. Here is an voltage source, and similar way the question asked here is IL of 0 minus IL of 0 plus IL of t for t greater than or equal to 0 and VL of t for t greater than or equal to 0. So before I enter into the sum, we have to know about 3 conditions. I'd say t less than 0, what happens to the circuit, what happens to the switch? Switch remains open circuit. So this will remain, so switch remains in short circuit. So what happens when it is in short circuit? It is being closed. So what happens is we will have a current flow across the circuit. So when I measure say I naught of t, that is at t less than 0, so it will be equal to say I is equal to V by R. So it is 24 divided by my say resistor value is 10, so I can write it as 2.4 amperes. So initial value of current is 2.4 amperes. Since this will remain as short circuit, since we have a say when we have t less than 0, it will enter into a steady state. So my say my inductor will be short circuit. If it is going to be a capacitor, then it will be an open circuit. So short circuit I have here. So I have measured what is an initial current value, that is your IL of 0 minus. Next we have to go to the next condition, that is at t is equal to 0. When t is equal to 0, already it is shown that it is open circuited, hence no current flows across the circuit. So at that time it has been the switch is open circuited. So under the next condition we have say at t greater than 0. So when t is greater than 0, so what happens to t greater than 0? First is I have to find out what is my IL. So IL will be my say, it is already given, it is 2.4 ohms. So when there is a current flow across the circuit, I can write it as minus 2.4 into 10 plus minus 2.4 into 5, which is equal to 0. So my IL will be equal to minus 120 amperes of current. So this is a final ampere of current that I get. After I have derived for IL, I have to calculate what is my IL of t when my t is greater than or equal to 0. So that is nothing but ISS plus k into e power minus tau minus t by tau. So here when I calculate this, so your IL of t is already, we know it is given to be as say it is 2.4. So it is 2.4 amperes, which is equal to ISS into k into e power 0. Okay, so first value when I calculate for ISS, it is usually 0 since there is no source involved in it. So when I calculate for IL of t, so I can write it as 2.4 is equal to k. Instead of k, I have to find out the k value. So I can write it as e power 0. So the k value is given by 2.4. So when I obtain the k value, I can substitute in the equation. It is 2.4 is equal to ISS, that is 0, plus k value is 2.4 into e power minus t by tau. So I have to calculate what is tau now. So tau is given by, in terms of, this is R and only L we have. So it is given by L by R equivalent. So when we calculate, L is nothing but L is 5 and R equivalent, this 40 and this 10 are connected in series. So I write it as 50. So it is 1 by 10. So this is tau equivalent. So when I substitute in this equation, I will get IL of t is equal to ISS is 0, k is 2.4, so it is 2.4 into e power minus 10t. So this will be my IL of t when t is greater than or equal to 0. Thank you.